saw what happens when hydrogen peroxide decomposes. This reaction is also called elephant's toothpaste. In a decomposition reaction, a single compound undergoes a reaction that creates more than one product. This simple equation shows that AB goes to A plus B. In order to understand this concept better, let's do an example using the reaction that we just saw. We started with hydrogen peroxide, which is abbreviated as H2O2. Also, if you think back to the reaction, you might remember seeing steam coming from the elephant's toothpaste. This tells us that water is one of our products. Also, if you have a compound that has at least 2 hydrogen atoms and at least 1 oxygen atom, you almost always have water as one of the products. Now let's figure out our second product. So we know that hydrogen, H2, is A, and oxygen, O2, is B, and that water, H2O, is A on this side of the arrow. So now we just need to know what B is on this side of the arrow. So if we go back to the original compound, we see that B is oxygen. So we know that oxygen is B over here. And we know that there's going to be 2 oxygen atoms because oxygen is a diatomic gas and always comes in 2s. So now that we have this equation, all we need to do is balance it. And in order to do that, we need to put a 2 here to make 4 hydrogen atoms on this side and 4 oxygen atoms on this side. We need to put a 2 here to make 4 hydrogen atoms and 2 oxygen atoms that we add to this 2 oxygen to make 4. So we have 4 of both types of elements on each side. And that is a completed decomposition reaction. The chemical reaction you just saw was a synthesis reaction between zinc and sulfur. In a synthesis reaction, you will see multiple reactants to start with that become one product at the end. This is the simple equation for all synthesis reactions. A plus B goes to AB. To make the chemical equation for the last reaction that we saw, let's start with the reactants that we already know were used. They are zinc and sulfur. Using this simple equation that we made at the beginning, we know that zinc is A and sulfur is B. And that is going to create a product that looks something like this. In order to determine if this is actually the compound that we're going to use, we need to figure out if it is a neutral compound or if it is charged. If it's charged, we need to make it neutral, but if it's neutral already, then we just keep it. Let's start with finding out the charge of zinc. I use this chart called Valences for Groups and Transition Elements. It gives you the charges of elements such as zinc, which are the middle elements on the periodic table that don't have a certain charge all of the time. So if you look down the chart, you can find zinc here at the bottom, and it tells us that zinc has a +2 charge. So we'll write that here. Sulfur, on the other hand, is one of the regular elements that you can find on the periodic table. So we find sulfur right here under oxygen, and we can see that it has a -2 charge. So we'll write that there. And 2 minus 2 equals 0. So we know that zinc and sulfur together in a compound, also known as zinc sulfide, is in fact a neutral compound. So now we need to see if this equation needs to be balanced. Because we have one zinc atom on this side and one zinc atom on that side and one sulfur atom on this side and one on that side, we have a balanced equation, and that is a completed synthesis reaction equation. Now that you know how to do synthesis and decomposition reaction equations, let's try some practice problems. Before I figure this one out, feel free to pause the video and try it yourself first. Because we have two reactants, we know that this is going to be a synthesis equation, and we are going to have one compound at the end for our answer. So let's start by just writing the 2 over here, because we know that we're going to have at least one silver atom and at least one chlorine atom in our answer. And to figure out how many of each one, we need to use the periodic table, or in this case, our valence for group and transition element sheet, because silver is another one of those middle metals that don't have the definite charges to them. So we just go down the list and find silver, and we see that silver has a +1 charge, so we can write that here. And now we need to go to the actual periodic table to find out the charge for chlorine, and we can see it here in this column, and we know that it has a -1 charge. Since we have a +1 and then a -1, we know that that is a neutral compound, and that can in fact be a answer to this equation. But since we have one chlorine atom on one side and 2 chlorine atoms on the other side, it is not a balanced equation, and we need to balance it. So in order to do that, we need to put a 2 here and a 2 here. This gets us 2 silver atoms on this side, 2 chlorine atoms, and then 2 silver atoms here and 2 chlorine atoms here. In this reaction, we have oxygen gas plus magnesium. If you'd like to do this reaction on your own first, pause the video now and then watch for the answer at the end. Because we have 2 reactants, we know that this is going to be a synthesis reaction and that we are going to have one compound for our product. Let's just put both of our different kinds of elements over here, and then we can figure out how many of each one we're going to need at the end. So magnesium goes first because it is the metal, and the metal always goes first, and then oxygen is going to go at the end. Let's figure out the charge for magnesium. As you can see on the periodic table, it is in this column, so it has a +2 charge. Now we need to figure out the charge for oxygen, and we'll come back to the periodic table. It's in this column right above sulfur, so we know it has a -2 charge. And since 2 minus 2 equals 0, this is a neutral compound, and it can in fact be the product for this reaction. However, we have one oxygen atom over here and 2 over there, so we need to balance it. Adding a 2 here and a 2 here will do that, because we have 2 oxygen atoms, 2 magnesium atoms on this side, 2 magnesium, 2 oxygen on this side. Okay, for this next reaction, if you'd like to work through it on your own, please pause the video now and come back later for the answer. Okay, so for this reaction, we know it's a decomposition reaction because we have one single compound in the beginning, and because of this, we know that we're going to have 2 products. So I'm just going to put the plus sign here so we remember. Okay, so we're going to use this simple equation to name this compound to make it easier for us to figure out the two products. So hydrogen is A and oxygen is B. And this is going to translate over here. A is here, B is here. And put the hydrogen here and the oxygen here. But remember, oxygen is a diatomic gas and always comes in twos, so we need to add a 2. Now that we have that sorted out, all we need to do to figure out the equation is to balance it. And since we have 2 oxygen atoms over here and 1 over here, it is still an unbalanced equation. So to balance it, we put a 2 here to give us 4 hydrogen atoms, 2 oxygen atoms, and then a 2 here to give us 4 hydrogen atoms on this side and 2 oxygen atoms. This is a more difficult reaction, and if you want to solve it by yourself, please pause the video now and then come back later for the answer. Okay, so this is a decomposition reaction because we have a single compound at the beginning and we are going to have 2 products at the end. So I'm just going to draw the plus sign here so we remember. And this is a particularly difficult problem because we have 3 different kinds of elements instead of just 2. So many people are going to say that Na2 is A and CO3 is B. When we are doing a decomposition reaction with 3 different kinds of elements, you are always going to have a compound. And like in the synthesis reactions, when you have a compound, it needs to be neutral. So let's see if CO3 is neutral. Using our periodic table, we can find that carbon is +4 and oxygen is -2. But since we have 3 atoms, it's going to be -6 because 2 times 3 is 6. And now we can tell that 4 plus -6 equals -2. So this is a charged compound with a charge of -2. So that means it cannot be one of our products. Now that we know that, we need to approach this decomposition reaction a little bit differently. If you look at it, you might be able to see a very common compound that we've seen many times in this class. So that one would be CO2. We know that CO2, or carbon dioxide, is a neutral compound, but let's check it anyway. So carbon has a +4 charge, and oxygen has a -2 charge, but since there's 2 oxygen atoms, it's a -4 charge. So 4 minus 4 is 0. So that is, in fact, a neutral compound. Now that we know that, we can figure out what the second product is going to be. Our leftover atoms are 2 sodium atoms and 1 oxygen atom. Now, if this compound is neutral, great, then that is our second product. But if it's not, then we need to split it up even more. And you can have more than 2 products at the end. So let's see if this is neutral. We'll go back to our periodic table and find sodium. So that has a +1 charge. But since there's 2 of them, we're going to have a +2 charge. And then oxygen over here has a -2 charge. And 2 minus 2 is 0, so that has a neutral charge. Now we need to balance the equation. Since we have 2 sodium atoms on both sides, 1 carbon atom on both sides, and 3 oxygen atoms on both sides, this is a balanced equation.